fury of nature? Is it divine wrath? The earth is a place of immense beauty and destructive power. We watch in awe as storms rage, volcanoes erupt, and earthquakes reshape the land. These events naturally lead us to question their cause. Are these simply natural phenomena, or is there a greater force at play? Are these events a sign of divine anger? Recent years have seen a marked increase in the frequency and intensity of typhoons and hurricanes, leaving a trail of devastation across Southeast Asia and North America. These events force us to confront the question, is God angry? While it's tempting to attribute these events to supernatural forces, it's important to consider the scientific explanations. Scientists have been studying these weather phenomena for decades, and their research sheds light on the factors driving these storms. This essay will delve into the recent history of typhoons and hurricanes, explore the scientific reasons behind their increasing intensity, and examine the measures we can take to protect ourselves from their devastating effects. This is not just an academic exercise, it's a matter of life and death. Understanding these storms, their causes, and how to mitigate their impact is crucial for the safety and well-being of millions of people around the world. By understanding the science and taking appropriate action, we can build resilience against these natural disasters and create a safer future for ourselves and generations to come. Typhoons in Southeast Asia, a recent history of destruction. Southeast Asia is no stranger to typhoons. These powerful storms, known as hurricanes in the Atlantic and Eastern Pacific, are a recurring threat to the region. Each year, the region braces itself for the onslaught of these natural disasters, which bring with them not just wind and rain, but a legacy of destruction and hardship. In recent years, the Philippines, Vietnam and China have borne the brunt of some of the most intense typhoons on record. These countries, with their vast coastlines and densely populated areas, are particularly vulnerable to the devastating impacts of these storms. These storms, with their torrential rainfall, powerful winds and storm surges, have caused widespread destruction, claiming countless lives and displacing millions. The aftermath often leaves communities struggling to rebuild, with homes, infrastructure and livelihoods destroyed in a matter of hours. One notable example is Typhoon Haiyan, known locally in the Philippines as Super Typhoon Yolanda, which struck in 2013. This storm is etched in the memories of many as one of the most catastrophic events in recent history. It remains one of the strongest tropical cyclones ever recorded, with sustained winds of over 195 miles per hour. The sheer power of Haiyan was unprecedented, and its impact was felt across the globe. Haiyan devastated the Philippines, causing catastrophic damage and claiming over 6,000 lives. Entire towns were flattened, and the scale of the destruction was almost unimaginable. The storm surge, reaching up to 20 feet, was particularly destructive, inundating coastal communities and leaving behind a trail of devastation. The surge swept away homes, vehicles, and anything else in its path, creating a scene of utter chaos. In 2020, Typhoon Goni, known in the Philippines as Typhoon Rolly, became the world's strongest landfalling tropical cyclone on record. This storm once again highlighted the vulnerability of the region to such extreme weather events. It slammed into the Philippines with sustained winds of 195 miles per hour, causing widespread damage and displacing hundreds of thousands of people. The destruction was extensive, with many areas left unrecognizable. These recent typhoons highlight the increasing intensity of these storms and the urgent need for better preparedness and mitigation strategies in the region. Governments and communities are now more aware than ever of the importance of early warning systems, robust infrastructure, and effective disaster response plans. The impact of these typhoons extends beyond immediate destruction. They disrupt economies, displace communities, and leave lasting scars on the landscape and in the memories of those affected. The economic toll can be staggering, with billions of dollars in damages and years of recovery efforts required. The frequency and intensity of these storms are a stark reminder of the destructive power of nature and the importance of understanding and adapting to the changing climate. As climate change continues to influence weather patterns, the need for comprehensive adaptation and resilience strategies becomes ever more critical. The future of Southeast Asia depends on our ability to learn from these events and to build a more resilient and prepared society. Hurricanes batter North America, a growing threat. Across the Pacific Ocean, North America faces a similar threat from hurricanes. These powerful storms, fueled by warm ocean waters, can grow rapidly in strength and size, posing a significant danger to coastal regions. The Atlantic hurricane season, which runs from June to November, has become increasingly active in recent years. This period sees the formation of numerous storms, some of which develop into major hurricanes with the potential to cause widespread destruction. Coastal communities along the Gulf of Mexico and the eastern seaboard of the United States have experienced a surge in the number of hurricanes making landfall, often with devastating consequences. These areas are particularly vulnerable due to their low-lying geography and dense populations. Hurricane Katrina in 2005 remains etched in the memory of many Americans as one of the deadliest and costliest natural disasters in U.S. history. The storm's impact was felt far and wide, leaving a lasting legacy on disaster preparedness and response strategies. The storm, which reached Category 5 intensity, devastated New Orleans and the Gulf Coast, claiming over 1,800 lives and causing billions of dollars in damage. The sheer scale of the destruction highlighted the need for better infrastructure and emergency planning. The levees protecting New Orleans failed, inundating the city and displacing hundreds of thousands of residents. This catastrophic failure underscored the importance of robust flood defenses and the dire consequences of their inadequacy. In 2017, Hurricane Harvey stalled over Texas, dumping record-breaking rainfall on Houston and surrounding areas. The unprecedented deluge overwhelmed the city's drainage systems and led to catastrophic flooding. The resulting floods caused widespread damage, displacing thousands and claiming over 100 lives. The storm's impact was a stark reminder of the vulnerabilities faced by urban areas in the face of extreme weather events. The storm exposed the vulnerabilities of urban infrastructure to extreme rainfall events, prompting a reassessment of flood control measures and disaster preparedness. Communities and governments alike were forced to confront the reality of increasingly severe weather patterns. These recent hurricanes serve as a stark reminder of the growing threat posed by these powerful storms. Each event brings with it lessons and challenges that must be addressed to better protect lives and property in the future. As the climate continues to change, scientists predict that hurricanes will become even more intense, with higher wind speeds and heavier rainfall. This trend underscores the urgent need for continued research and innovation in storm prediction and mitigation strategies. This underscores the urgent need for proactive measures to mitigate the impact of these storms and protect vulnerable communities. Investments in infrastructure, early warning systems, and community education are critical to enhancing resilience against future hurricanes. The science behind the storms, understanding the increase. The question arises, why are these storms becoming more frequent and intense? What is driving this alarming trend? The answer lies in the complex interplay of factors that govern Earth's climate system. These factors are interconnected and influence each other in various ways. Scientists have identified several key drivers contributing to the observed increase in typhoon and hurricane activity. These drivers are rooted in both natural processes and human activities. One of the primary drivers is climate change. This phenomenon is reshaping our planet in profound ways. The Earth's atmosphere is warming due to the increased concentration of greenhouse gases, such as carbon dioxide released from human activities like burning fossil fuels. These gases trap heat, leading to a gradual increase in global temperatures. This warming trend has several implications for hurricane formation and intensity. Warmer temperatures create a more conducive environment for these storms to develop. Warmer ocean temperatures provide more energy for hurricanes to form and intensify. The heat from the ocean's surface waters acts as fuel for these powerful storms. Hurricanes draw their energy from the heat stored in the ocean's surface waters. As the ocean absorbs more heat, the potential for stronger hurricanes increases. As ocean temperatures rise, so does the amount of heat available to fuel these storms, leading to more powerful hurricanes with higher wind speeds. This results in more destructive storms that can cause significant damage to coastal areas. Warmer air can hold more moisture, leading to heavier rainfall during hurricanes. This increased moisture content can result in more intense and prolonged rainfall events. This increased rainfall can exacerbate flooding, as seen during Hurricane Harvey, and lead to more widespread damage. The combination of heavy rainfall and storm surge can overwhelm drainage systems and flood defenses. Furthermore, rising sea levels, another consequence of climate change, make coastal areas more vulnerable to storm surge, the deadliest hazard associated with hurricanes. Higher sea levels mean that storm surges can penetrate further inland, affecting more communities. Understanding the scientific basis for the increase in typhoon and hurricane activity is crucial for developing effective mitigation and adaptation strategies. By studying these patterns, scientists can better predict future storms and help communities prepare. By addressing the root causes of climate change, we can mitigate the risk of these extreme weather events and create a safer future for ourselves and future generations. Transitioning to renewable energy sources and reducing greenhouse gas emissions are essential steps in this process.